night you watched that little video on Pythagorean Theorem, and essentially what it said was that the Pythagorean Theorem only works on a right triangle. And it says that a squared plus b squared, where a and b are the legs of the triangle, we'll draw a picture in just a minute, is equal to c squared, the longest side, or the hypotenuse. Okay? So when we look at a right triangle and we give some names to this vocabulary, here's my right triangle. The two sides that touch the right angle are called the legs. And they are A and B. You can call this one B and this one A. It doesn't actually matter. But the legs touch the right angle. Okay? These are the shorter sides. Oh, I forgot my T. Short. Okay? The side across from the right angle, okay, doesn't touch the right angle. This is your C. This is your longest side, and it is called the hypotenuse. Okay? Kind of a long word. So what we're going to look at today are some examples. I know yesterday when you watched the video, he had the rope and he had the tiles, and we're going to look at some of that. This is also going to relate back to what we talked about with squares and square roots, so make sure that you have your calculator handy in case we have to do any calculations, okay? Let's go and look at an example. You'll notice that this example looks a lot like in the story, right? Given what you know about right triangles, what is the area of the largest square shown above? Now, also what we know about squares and square roots. So if you remember, here's our right angle. Look, they've already labeled A, B, and C for us, where A and B are our legs, our shorter side. C is our longest side, our hypotenuse. Now, the formula, we're going to focus, just look at the square for a minute. If the area of the square is 49, how do we find the side length? How do we find area? Area is what? Side squared, right? So if I want to find just the side of a square, what do I do to the area? Nope, we're not going to divide. That would give us, that's if we have perimeter. Yes. Take the square root. If you want to know the side length, you have to take the square root of the area. Okay? So if you recall when we did squares and square roots. So what does that mean about this this square right here and this side of the triangle? How long is side A? Yes. 7. The square root of 49, so A equals 7, right? And you could even count it, right? Sometimes they don't give you a picture with boxes though. Yes?
It says 49 square.
So what is the side length of this square here? 8. Square root of 64 means B is 8. Now, what we know from our video last night said A squared plus B squared equals C squared, right? Guys, they've already squared our A and B if they give us the areas. Okay, but I want you to see how we go back and forth. So we could plug in 7 squared if we wanted to, but we know it's 49. We could do this. Do you see the relationship here between the side length and the area? Okay. So what would we need to do? What is 49 plus 64? 103. And that is c squared. So remember, if it is squared, that is our area. So, excuse me, 113. Thank you, sorry. So you could come up here and say the area of this square is 113. Now, that is not the length of the, what do we call this side? That is not the length of the hypotenuse. If you did 113 square rooted, and you can use your calculator for that, it would be what? 10.6301. So we could call it what? 10 point what? 10.6. So we could say C equals 10.6. Okay, are you seeing the relationships between the squares and the square roots we did before? So what this is saying is if I take 49 squares and 64 squares, I would get the squares for the longest side, just like when he did the red and the blue, right? And this was red and blue. All right, you want to try another one? All right, let's look at this next one. Now, this one does not have labels for us. So we need to identify our right angle. So what is this side? Is this A, B, or C now? This is C. Good job. What is this side? Okay, B or A, doesn't matter. And we can call this one A. So what do we know? It says, what are the areas of the two smaller squares? Well, how do we figure that out? Give me something. Someone. Shout it out. Count the sides, right? So 1, 2, 3, 4. So A is 4 units long. B is how long? 1, 2, 3, 4, 5. Okay, yay. Well, that doesn't tell me the area, does it? How do I find area? We got to square it. So what is the area of A? 16. What is the area of B? 25. So we can say, because these are the smaller squares, this is A and B, so we can say the area of A is 16. The area of B is 25. Well, that's wonderful. What does that tell us? Look at that next question. What is the area of the largest square? Well, what does the Pythagorean theorem say? It says A squared plus B squared equals C squared. Well, we've already squared A and B, didn't we? Isn't that how we got the area? So we can say 16 plus 25 equals what? 41. So the area of C is 41. Yes? So what are the side lengths of all three sides of the triangles? Well, we know that A was what? And B was... So how are we going to find C? If the area is 41, how do we find just C? Take the square root. So I can say the square root of 41, and you're using your calculator to make that happen, right? What is it? 6.4. So that is my measure of C. And what is C called again? The hypotenuse. Now, you can also use your calculator. If we have these numbers like this, we can go to our calculator. Remember, it'll tell us a true-false statement. We can say 4 squared plus 5 squared equals 6.4 squared. Okay, it's going to say false because we rounded it. Sometimes it's ugly. Let's do this. If I go up here to this, it still says false because it doesn't like that we rounded it, but you can do that. I'm not really, oh, because see how it says it's false because we're approximating because it rounded, but that's okay. You could say 4 squared plus 5 squared equals, how did we get this number? The square root of 41, and we would square it. Oh, it does, it's because it's approximating. Okay, so if it's not pretty, it's not going to work that nice. That's okay. What about another one? Yes, are we feeling okay?
Yep.
All right, let's turn the page. What's different on this one? We don't have a grid. Right, so let's fill in this box what we know. The area of square A is what? 36, and the area of square B is 81. So we know that when we square these two sides and we add them, we should get C squared. So what would be the area of C? (117). This is our side squared because it's area. How do we get our side length? Take the square root of the area. So what is the side length of A? 6. What's the side length of B? 9. What's the side length of C? 15. Is it 15? No.
10.8.
How'd you get that? Square root of 117. 10.8, we're rounding it. Now, if we know, we can even go through here. We can say this is 6 and this is 9. Okay? Is everyone okay with how we got that? Do you want to try the next one? It's a little tricky. Let's try it and we'll come back. So, some of you are like, what? So let's fill in what we know. We know the area of B is 25. Remember, this is our side squared. This is our square root of our area. And we know if we take A squared plus B squared, we get equals C squared. But this time we have C. So something plus 25 is 169. What do we need to do there? We need to subtract 25 from 169, and we get 144. Right? Why does that not make sense? Picture may not be drawn to scale. It says it up here. So let's tell me about the side length. What is the side length? If this is 144, what is the side length of A? 12. What's the side length of B? 5, because you're taking the square root. What's the square root of C? 13. Okay. Because this one is nice, this one will check in the calculator. So we can say 12 squared plus 5 squared equals 13 squared. Very nice. So we can check in our calculator if they are what we call, remember, perfect squares. They come out to a nice number. All right. I do want you to see how this works with the Pythagorean theorem. A squared plus B squared equals C squared. If I do not know A, I'm just going to leave it A squared. My B is 5. My C was 13. We're going to do order of operations. Right? Exponents first, and then we're going to undo our add subtract. A squared equals 144. How do I undo a squared? I take the square root. If I take the square root on one side, I have to take it on the other. Square root of 144 is 12, and that's where we're heading with this. Okay? Now, this is what we call, let me use a different color, because these all came out to nice, neat, perfect squares, this is called a Pythagorean triple. When it comes out to nice, neat numbers. And we can, if I applied a scale factor of 2 here, another Pythagorean triple based off this would be 24, 10, 26. Okay? I have one more that I would like for you to do. I'm going to let you try this one on your own, and then we'll come back together. I want you to try this one. All right, so let's have a glance here. What did you fill in? What did you know about, just by looking at this triangle, what did you know? Shreya? The side length of A is 6. It's not labeled, but it gives it to you. 6. What else do we know? Area of B is 64. Okay, so that's all we're given. So what can we determine from that? Yep. 6 squared is 36. A squared plus B squared equals C squared. 6 squared is 36. What's the side length of B? 8. So we can say 8 squared, and we got the 64. So what is C squared? 100. So what is the side length? 10. Hey, guess what that's called? This is another Pythagorean triple. Now, this is actually, if you look, these are all multiples of 2. So the most common Pythagorean triple is a 3, 4, 5, which is what that is. All right, last one. What if I don't give you area? What if I just give you side lengths? We're not going to do all of these. Right here. Is this a, no, we were going to do this one. This one or the one above it? This one. So what is 11? A. What is 19? C. That is your hypotenuse. Always label A squared plus B squared equals C squared. This little table here we're going to start getting away from. So we have 11 squared plus B squared equals 19 squared. What do we know? What's 11 squared? 121 plus something equals, what's 19 squared? 361. So what do we need to do to solve this equation? Good. 361 minus 121. And we get 240. Now that's B squared. That is the area, right? This, when we squared these were all areas. But I want just the side length. So how do I get that? Take the square root. What is the square root of 240? 15 point what? 5-ish. All right. So how do we feel about Pythagorean theorem right now? Awesome.